Line 22, 7b97z57j, Geocentric Geographic Conversions, UFO, Inverse Equations, 5G Wow Seti. There's the alien radio signal. Okay, so the keyword research, datum, geocentric geographic space mapping coordinates, rotation vectors for UFO mapping, outer space transport vehicle, found on line 22, wow data. So, September 19th, we were looking at line 22, 7b97z57a, coastal navigation, reference points, outer space UFO, ballistics formula, 5G Wow Seti, and now we're up to video J. So you would start at A if you're going to look at this series of videos. This is part 2 of I, just so you know. If you started looking at the I video, you want to look at the J video, the I video first and then go to J. So I googled the keywords bore alignment laser, and then I got to datum shift transformations, coordinate Molodensky geocentric geographic transformations. The data is from August 2009, presented by R. Knippers. Quotes and diagrams are from the blog cartoweb.itc.nl. So we're looking at 532 geocentric to geographic conversion. The inverse equations for the reverse conversion are more complicated and require either an interactive calculation, iterative calculation of the latitude and ellipsoidal height, or it makes use of the approximating equations like those of Bowring. These last have millimeter precision for earthbound points, i.e. points that are at most 10 kilometers away from the ellipsoidal surface, any point on the Earth's surface. So I'm going to refer to the OGP Guidance Note 7 for the formulas and a detailed explanation of the formulas. An example, the Potsdam XYZ coordinates of the given point in the state of Baden-Württemberg, which is in Germany, are those numbers. And these Potsdam XYZ coordinates were computed from the iterative XYZ coordinates by applying a Helmert datum transformation and applying the inverse equations to the given point results to the following Potsdam FLH coordinates. Tool for the conversion from geocentric coordinates or 3D Cartesian to geographic or geocentric external link. You would click on this link and it'll help you convert them if you need to do that. 5.4 2D Cartesian coordinate transformations. 2D Cartesian coordinate transformations can be used to transform 2D Cartesian coordinates xy from one 2D Cartesian coordinate system to another 2D Cartesian coordinate system. The three primary transformation methods are 1. The conformal transformation, 2. The affine transformation, and 3. The polynomial transformation. A conformational transformation is a linear or first order transformation and relates to 2D Cartesian coordinate systems through a rotation, a uniform scale change followed by a translation. The rotation is defined by one rotation angle A and the scale change by one scale factor S. The translation is defined by two origin shift parameters XO and YO. The equation is as follows. Okay, where A equals S cos A and B equals S sin A. The transformation parameters or coefficients are A, B, X, O, Y, O. An affine, number 2 is an affine transformation, is a linear or first order transformation and relates to 2D Cartesian coordinate systems through a rotation, a scale change in X and Y direction, followed by a translation. The transformation function is expressed with 6 parameters: one rotation angle A, 2 scale factors, a scale factor in the X direction, SX, and a scale factor in the Y direction, which is SY. And the two origin shifts is XO or YO. The equation is as follows. Okay, where the transformation parameters or coefficients are A, B, C, D, XO, YO. The difference between a conformal and an affine transformation is illustrated in the figure below. Both are linear transformations, which means that the lines of the grid remain straight after the transformation. A, the uniform scale change of the conformal transformation retains the shape of the original rectangular grid. The different scale in X and Y direction of the affine transformation changes the shape of the original rectangular grid, but the lines of the grid remain straight. A polynomial transformation is a nonlinear transformation and relates to 2D Cartesian coordinate systems through a translation, a rotation, and a variable scale change. The transformation function can have an infinite number of terms. The equation is as follows, with all those little letters and numbers. Polynomial transformations are sometimes used to georeference uncorrected satellite imagery or aerial photographs, or to match vector data layers that don't fit exactly by stretching or rubber sheeting them over the most accurate data layer. The figure below shows a grid with no uniform scale distortions. It may occur in an aerial photograph caused by the tilting of the camera and the terrain relief topography. An approximate correction may be derived through a high-order polynomial transformation. The displacements caused by relief differences can be corrected using a digital elevation model, DEM. And the keyword datum transformations via geocentric coordinates, so 521 to 522, continues in the next video. Thanks for watching.